So let's analyze the peak search problem a little bit more carefully. This problem does fit in the mold of finding the value in a list because whatever we are looking for is indeed in the list. However, there are two issues, very important ones. Obviously, this list is not sorted because remember the data first increases, then there's a peak, and then the values start to decrease. So, which means that there is a clear peak. It's not ascending, not descending. We have already said that the extremes do not hold the peak. So, the data is clearly not sorted, which kind of complicates things a little bit. And we also do not know the value of the peak, which means that look, this is not a typical search problem where we know we are looking for this value. We just know there is a peak somewhere. We do not know where it is, and we do not know how large it is. Our task is to find that peak. So a little bit different, though there are similarities. Now, what are the options that we have? Well, first thing first, linear search. We can always start searching from item one and keep searching until the last but one item. Basically, I can just say that, okay, look, the very first item where I find that values n minus 1 is less than values n, which means, look, there's an increase here, and values n plus 1 is less than values n. So basically, values n is the peak, right? So the first item where I find this could be a peak. So that's like a linear search approach. Clearly, this will be time consuming, especially if the list is long. And basically, we're going very slowly, climbing up, searching every point till we start seeing there's a switch, right? So yeah, fair enough, it will work, but clearly will be inefficient. And then, of course, there is the option of doing jump search. So you start making larger jumps till you, let's say, hit a certain situation. And then we do a linear search. But in this particular problem, in fact, it's a little bit more tricky because, we may have overshot the peak but not realized it because we may still be higher than the previous, let's say, search value. So this could be a little bit more tricky. But what we really want to do is binary search, because we know it all too well that binary search is much more efficient than linear search as well as jump search. Question, however, is how do we do this? Because this data is not sorted. Well, an interesting insight comes from this observation that even though the data is not sorted, in fact, at all points, I have a very clear idea of whether the peak is ahead of me or is it behind me. This is almost like our threshold crossing problem, which we just saw. Basically, if the gradient is positive, which means that if we are kind of looking, let's say, upwards, then we know that the peak is ahead of us. And if the gradient is negative, then we know that the peak is behind us. In fact, this one insight is what basically tells us that binary search is possible. All we have to do is to search in the middle. For example, if we find that the gradient is positive, we are sure that the peak cannot be on the left side. So which means we can immediately discard the left half, go search on the right half. Now, when I do that, for example, in this data set, I'll end up somewhere here. Now I know that the gradient is negative, which means that the peak has to be behind me and I can discard this half of the list, right? So, and so on. So we can just think about it. You can keep going, let's say, narrower and narrower till you find this peak. So once again, like I said, the important bit is we have a clear demarcation where the peak, or say the target, is ahead or behind, and that is exactly what will drive our binary search. So just to summarize, basically we have a clear demarcation and understanding of whether the peak may be ahead or behind us. Even though the data is not sorted, we can just look at the gradient at all points and basically use that to guide the binary search, as we will see in the next video. I hope you found this interesting. Do think about it. The message as to where binary search is applicable is in fact very clearly illustrated from this. Our website www.ybyte.in has lots of materials with which you can learn algorithms and programming in a fun way. Take care and enjoy coding.